then what's your symbol for variance?
Sigma squared.
So it's gonna be sigma squared. So here's the form of your answer. Sigma squared is gonna be between two blanks. So do you see the forms are the same? It's always a population symbol in the middle. These are less thans, and there's a number on the left and a what? Number on the right. All right, here's the difference though. This one we're not doing on the calculator. Okay, this is coming from a different picture. Now, the others were based off of a normal curve, correct? All right, this one's going to be based off of something called a chi-squared distribution. And basically, it looks like a normal curve on a bad day. And by that, I mean, it's still one of those kind of bell-shaped curves, but it's not symmetric. And the hump's not in the middle. All right, so it looks more like this. Now remember at the beginning of the semester, we talked about graphs being skewed or symmetric. That one's skewed. It's skewed right. Now remember, it's named by the longer tail, not where the hump is. Not what I would have done, but I didn't get to know. Okay, so it's skewed to the right. Now here's what's going to be true though. You know how the normal curve, remember when I worked the first one, the long way on proportion, and I drew the normal curve and found my z-scores? This is going to be similar to that, except you do have two tails. There's a tail on this side, and there's a tail on this side, but they're not the same shape. Okay. But they do have the same area. Now, if you were two, this would be a problem, but you're not two. You know by your age that that different shapes can have the same area on the inside. All right, 2-year-olds do not know that. If you've never experienced that, just get two different size glasses and try to give them the same amount of juice. It's terrible. They can't do it. If you got a tall, skinny glass and you got a short, fat glass, and you got two children that are 2 years old, and you pour 8 ounces of juice in both glasses, one's going to start crying. You know which one's going to be upset? The one with the short glass. He's going to think, or she's going to think, that you gave them less juice, because they just look at the height. So it's the funniest thing. You can actually empty one of them out. They can watch you pour the short fat one into the tall skinny one. You can ask them, do I have less juice, the same, or more? And then I'll tell you, now you got what? More, magically. And they can watch you pour that same amount back in the short fat one and tell you, now you got what? Less. They didn't see any spill, but it's just magic. When you're 2 years old, it's just magic. Things appear and disappear. Okay, math is magical, but it doesn't have magic in it. So things are not going to appear and disappear. Now, do you remember on the normal curve, you had a z-score here and you had a z-score here? This time, those are not going to be z-scores. They're going to be something called chi-squared scores. Now, the Greek letter chi looks like an X. Okay, so this is chi-squared and this is chi-squared. Now, you're not going to square anything. That's just its name. All right. Again, I'd have named it something, but I'm not in charge. All right. So that's just its name, and they were very creative. This one has a subscript of L because this is chi-squared on the left side, and this one has a subscript of R because it's a chi-squared on the what? Right side. And those two numbers we're going to need, because you're going to have to get the numbers and the blanks by hand. And the only thing you're going to have to find really are these chi-squared numbers. All right. Now, let's do this then. talk about how you find the chi-squared numbers. Now, first of all, let's do away with a myth, or at least the beginning of a myth. Chi is a Greek letter. It's the first letter that Christ starts with. All right. So when monks had to translate the transcripts manually, before the printing press, they would hand copy scripture. Sometimes the monks would not feel worthy to write down the name Christ. So they would simply write the first letter that it started with. And what does it start with? So what did that letter stand for? Christ. Okay, we're not Xing Christ out of Christmas. All right. Originally it was kindness. Is everybody with me? And so that's kind of the origin of that. So it may have turned into that, but that's not the way it started. Now, here's what you're going to do first. The first thing you're going to have to do is you're going to have to kind of draw the chi-squared picture, the chi-squared distributions. Everybody with me? So kind of a lopsided looking normal curve. The second thing you're going to do is you're going to find alpha. Now, we did this before. We did a similar process when we were looking for z-scores. Do you remember to find alpha, we said 1 minus your confidence level? And then if you remember, what were the subscripts on those z-scores? They weren't alpha, they were alpha what? Divided by 2. So you're going to have to compute alpha divided by 2. And remember what that is. That's the area in each tail. In other words, that's the area for one tail. All right. And then I'm going to say, put those values. Oh, that's areas. Let's put that. All right. Put those area values on pictures. I'll show you what I mean by that in a second. All right. You're going to find something called the degree of freedom. And the way you do that is your degree of freedom. I'm just going to put DOF for degree of freedom. It's real easy. It's just n minus 1. And then you're going to use table, I think it's A4. Yeah, you're going to use table A4 to find the chi-squared values. Now you write that down and then we're going to play with it in a minute. We're going to learn to find those chi-squared numbers before we go find the formula for variance. Okay. We're going to add a few things kind of next to some of the steps for clarification for you. All right, but I'd rather you have them already written down so that you're paying attention when you do. All right, so the first thing is this. If you've got a hard copy and it's new, there should be one of these what I call flippy fold out things. It's a formula sheet, looks like this. All right. Table A4 is on there. All right, it's called the chi-square distribution. If you've got a used book, you may not have one of those. They're also, the table's also in your appendix of your book. Okay, you can see what page the chi-square is. Looks like it's on page 563. Okay, so page 563 or this flippy fold out. Right. But that's what you're going to need to find the chi-squared values are on this part. All right. Everybody okay? Now let's kind of go do one. Here's what I mean. What if I told you that you had a study of 22 people And you want to do a confidence interval that is 95% confidence interval for standard deviation. So what we're going to do first is we're going to find the chi-squared numbers, and then we'll go do some problems and actually do the confidence interval. But the only challenging part, which isn't really that challenging, but the only thing that's going to take, God bless you, a little bit of effort is to find the chi-squared. Okay. All right. So the first thing I do is I do what? I draw my what? Draw my picture. All right. So I've got this chi-squared thing. All right. And I've got an area on the left, and then I've got an area on the right, and I've got a chi-squared left, and I've got a chi-squared right. I'm going to need those two values when I'm finished. All right. Everybody okay so far? So that's what I mean by draw the chi-squared picture. Now, it says find alpha. All right, how do I find alpha? Remind me, what's alpha? 1 minus, what's my confidence level on this one? 95%. Now, what have I got to change that 95% to? 0.95. So what is alpha? 0.05, 500. Everybody understand that? So alpha is just 1 minus your confidence level. By tracking? All right, what's my next thing I've got to compute? Alpha what? Divided by 2. All right, take that alpha, you got that calculator and half it for me. What do I get? You got the calculator? 0.0 what? 25. Now, what is that 0.025? That's the area in what? Each tail. So put it on the picture. All right, so you might put in parentheses, or put down here, put on picture. Okay. So this area right here is 25 thousandths, and this area right here is 25 thousandths. So I drew the picture, I found alpha, divided by 2, and I put them on the picture. Okay, now, what have I got to find next? I got to find this thing called what? The degree of freedom. Now, how do I define my degree of freedom? Remind me. My degree of freedom is what? N minus 1. What does N stand for the whole semester? What's my total in this one I made up? 22. So what's 22 minus 1? 21. Now, the degree of freedom tells you what row of the table to use. Now, I want you to look at your table. Do you see row 21? You do, don't you? So now you've narrowed it down to about 8 or 10 numbers out of the whole table. But I want you to notice what happens when you get to 30 on your table. What's the table start doing when you get past 30? It starts jumping up by what? 10s. Well, here's what we're going to do. I'm not going to make you interpolate the table. In the real world, I'd interpolate the table. But I'm going to let you, if your row you need is not there, I want you just to pick the closest one. So here's what I mean. What if you were sampling 93 people? If you were sampling 93 people, what would your degree of freedom be? 90 what? 2, right? So you go look at a row 92 and what? There's not a row 92. So in your table, what two values is 92 between that you do have? 90 and what? 100. Which one is 92 closer to, 90 or 100? Then you do row 90. So do you understand? Now, if you've been sampling 38 people, what would your degree of freedom be for 38 people? 30 what? 7. Is there a row 37 on this table? What? No. What are your two choices? 30 or what? 40. Which one are you going to pick? 40. 37 is closer to 40 than 30. Are we okay? All right, now, then it says use table A4 to find the chi-square values. Now, let me show you what I'm talking about. You know what row to look on, right? Question, Abigail?
What do you want us to do for our degrees of freedom that's like 35?
I would just go up, but I would probably take either one because technically it's exactly the same distance. Okay, now on your table, look what it says at the top. It says area to the what? Right. You have to have the area to the right to know what column to look under. All right, now, so here's what I would do if it were me. When I say use the table A4 to find the chi-square values, I probably would draw two different pictures to finish the problem. Now I'm going to erase this. It's on your. Get myself a little more room. So I'm going to go back. My degree of freedom, we understand, was 21. Remember? Right? Remember that tells me what row. Now it doesn't matter which one of these two values I find first. Most people, the right one's quicker to find first. Here's why the right one's usually quicker to find first. If I'm doing chi-squared R, what's the area to the right? Point what? 025. That tells me what column we're looking at. So look on your table. Where the row and the column cross, that's the value you need. So what row am I on? Remind me, I'm supposed to be on row what? 21. What column am I supposed to be under right now? 0.025. What number is on that row in that column? 35 point what? 479. So this is 35.479. I'm gonna find it over here and then put it right there. But I've still got to find the one on the what? On the left. So I'm going to redraw the picture. Now here's the catch. I know that tail area right there is 0.025. But to read this table, it says at the top, what do I need? I need the area to the right. All of this area to the right of that value I need. All right, if this is 0.025, what's that going to be? Point what? 975. How'd you get that? 1 minus it, right? That's the area I need. Because to read the table, you have to have the area to the, what does it say at the top? To the right. So now I'm still on row what? 21, but I go out to point what? 9 what? 75. What number is sitting there? 10 point what? 283. But sometimes when people try to work on this one picture, they can't get the area to the right. They get confused. So redrawing them and getting them separately works out better for most people. Are we okay? All right, let me let you try one then. All right, suppose I tell you that your study had 47 people in it. Okay, there are 47 people in the study. And I want a 90% confidence level. Find me your chi-squared. Find me your chi-squared left and chi-squared right. 47 people in the study, 90% confidence for that standard deviation. Go find me the chi-squared left and the chi-squared right numbers. All right, see how you did. All right, so the first thing I do is I draw my picture. Now I've got to find alpha. Remind me how I find alpha. What do I do? 1 minus my confidence level. So 1 minus decimal 9. So what'd your alpha come out to be? Point what? So 1/10 or 10/100, same thing. What'd you do with that alpha? You had to remember to do what? Divide by 2. So if you take that alpha and you divide by 2, what's half of 1/10? So do we understand that that's the area right here, 0.05, and that's the area right here, 0.05? Is everybody okay on doing that part? Now, I've also got to find my degree of freedom, do I not? How do I define my degree of freedom? Remind me. All right, n minus 1. What's your total? 47. So what row are you going to be looking for? 40 what? 46, right? But when you look at your table, what? You don't have a row 46. So what are you going to have to use instead of row 46? Row 50. Is everybody clear? Now, I've got to know what column to look under. And so usually you're better off drawing 2 different pictures when you go do that. It doesn't matter which one you do first. It's just usually the right one's a little easier to see first. So chi-squared right, that shaded area right there is 500s, correct? So remind me, what row am I on? 50, and this is my column. So if I'm on row 50 and I'm under the 0.05 column, what number was sitting there did you pick? 60 what? 7 point what? 505. So that one is 67.505. Everybody okay? All right, now I've got to do the left one. Right, so now I'm over here doing chi-squared left. Now, I know that area right there is 0.05, but I need the area to the what? I need the area to the right according to the table. So if I know this area, how do I get that area that I need? 1 minus that. So what row, what column am I looking under here? Point what? 95 column. All right, so if I'm still on row 50, but I'm under the 0.95 column, what number did you grab? Point, what, 30 what? 34 point what? 764. So does everybody feel comfortable reading the table, finding the chi-squared numbers? Are we good? All right, now, then let's go work the problem. Okay. And after we get the problem worked, I'll kind of go back and talk about this chi-square distribution for just a second to clarify a couple things. Look in your books on page 340, we're going to work number 10. All right. 340, number 10. Number 10. Now, here's what it says. In a test of weight loss programs, 40 adults used the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2 1/10 pounds with a standard deviation of 4 8/10 pounds. Construct a 90% confidence interval estimate of the standard deviation of weight loss for all such subjects. Now, is this a sample size problem or a confidence interval question? Which one is it? It's confidence interval. It says construct a 90% confidence interval estimate of what? Standard deviation. Now, I do not understand why this happens, but every time on the third test, I tell somebody to do a confidence interval for one thing and they do it for something completely different. I'll say do it for standard deviation and they'll go do it for mean or proportion. I can't give you any partial proof. So if it were me on my homework and on my test, as soon as I saw construct a confidence interval estimate, I would underline of what? So what did we underline in our book then? Of what? Standard deviation. Now, look at your formula sheet and find me a confidence interval for standard deviation or variance, because it's not on your calculator. And copy it on your paper. All right, so what does it say? Confidence interval for what? Does it say variance or standard deviation? What does it say? It says variance. So this is what I'm copying on my paper. And that came off the formula sheet. So do you have to memorize that? Yeah, it's on the formula sheet. That's the same. Then you'll get a clean copy of that when you take the test. Now, there's an and in that formula. What's in the whole time in every formula that you encounter in here? What's my total on number 10? How many were in the study? 40. All right, so N is 40. Now, what does S stand for? Standard deviation. Did they give me the standard deviation? What is it? 4 8/10. All right. Now, according to this formula, what have I got to do to that standard deviation? I've got to square. Now, what do you notice about the numerator over here and the numerator over here? They're what? They're the same. N still going to be 40. Standard deviation they still gave me was 4 8/10. So that's actually the variance when you square. So here's what I meant. The only numbers that they don't give you are the chi-squared numbers. But don't you know how to get chi-squared numbers now? So go get me the chi-squared left number and the chi-squared right number. And then we're gonna substitute them in.
The square root of the number that is passing.
Yeah, in other words, there'll be one extra step. So that's what I read.
What's the page for the chart in the back?
I have to look. Was it 63 or something? Okay, 563. All right, you help me. So if you're not finished, just kind of stop and watch and make sure you're good. I gotta find my alpha. So 1 minus, what was my confidence level on this one? What did they want on number 10? They wanted what? 90%. All right, so you had 1 minus 9/10. So again, it's like last time, what did alpha come out to be? 1/10. Everybody good? Then what did you do to that alpha? You divided by 2. So when you took that 1/10 and you halved it, didn't you get 500s like you did just a second ago? So there's 500s for the right tail area, there's 500s for the left tail area. Is everybody okay on that? Now, you had to find your degree of freedom. Remind me how do I find degree of freedom? N minus 1. What was your total on this one? 40. So 40 minus 1 would be what? 39. Now, that degree of freedom tells me what row. So if there was a row 39, I would use it, but what? There's not. They didn't want the table to go on for pages, so they just started skipping. So I would look for row 39, but it's not there. So which one is there that's the closest? So I'm going to be on row 40. Does everyone understand how I find the row? Now, I told you to find the columns. I would probably redraw the picture 2 times, just as me. So if I'm doing the right one, if I'm doing this chi-squared right, that area right there is 0.05. So I'm on row 40. So I'm under the same column I was under a minute ago, but I'm on a different row. So if I'm on row 40 and I'm looking under that 0.05 column, what number did you write down? 55 point what? 758. 55.758. Is everybody okay on finding that one? All right. Now I'm going to find the left one. I'm going to erase because the board got a little crowded. All right, so I'm going to erase and do the left one. Now again, I need the area to the right. So I know that the area to the left is 0.05. So what's the area to the right? Point what? 95. So again, now I'm still on row 40, but I'm under the 0.95 column. All right. So 0.95 under row 40. What number did y'all get? 26 point what? 509. Is there anybody that couldn't find those values? Now, here's where you got to be careful and read. The left one goes where over here? On the right, and the right one goes where over here? They go like this. Is everybody with me? I'll explain why in a second. So if you just read, where, put the L where it says L, put the R where it says R, you won't be confused. So this one is the 26.509 number, and this is the 55 and 758 thousandths numbers. Everybody good? Now, let's go see if you got the right calculations. You got to follow your order of operations. So what am I going to do first? What's the first thing I do in order of operations? Parentheses. So I've got to do 40 minus 1. What's that going to get me? 39. Now, I'm not going to waste the marker, so I'm just going to do it right here. Now, do I multiply or do exponents first? What do I do first? Exponents. So if you took that 4 8/10 and you squared it, and then you multiplied by 39, did you get 898.56 on the top of that? Is everybody able to get that? But this time I'm dividing by a number a little more than 55, and this time I'm dividing by a number a little bigger than 26. All right, so if I do 898 and 56 hundredths divided by 55.758, looks like I got a number a little bigger than 16. Is that what y'all got? And then on the right, I'm doing 898.56 and I'm dividing by the number a little bigger than 26. And I got a number a little more than 33. Everybody agree with that? Now, if it had said, because sometimes it will, if it had said write a confidence interval for variance, I would stop and box that. I would be finished. But this one didn't say do it for variance, it said do it for what? Standard deviation. So like Mitch said, how do you go from variance to standard deviation? I got to take the square root all the way across. And the square root of sigma squared is just what? Sigma. All right, so if I do the square root, I get about 26 point, oh, wait a minute. Y'all get a number a little more than 5, maybe 5.8 or 5.82, something like that, round just a little bit. And I got to just square to this number, so it should be a little more than 4. Looks like I got about maybe 4.01. So there's my final answer. So it's not hard, just the calculator's not going to do it for you. Is everybody okay on that? You feel good about it? Now, couple of quick things to make sure we understand why it's doing this. Let's do some smaller numbers that you understand. Questions, Savannah?
You can round the.
Yeah, you can round this, just don't round up here, okay? Now, when numerators match, don't these numerators match? What happens to fractions when you divide by bigger numbers to the fraction? What does it do? Shrinks. A sixth of a pizza is less than a what? Half a pizza. So that's the reason that the bigger number had to go on the left and the smaller number had to go what? On the right. Because when you divide by bigger numbers, the fraction's smaller. So the author had a choice. If he had put the left one on the left, if he put this one over here, this number would have been bigger than what? That number. And so then that interval would have looked like that, which he thought would freak you out. Because the other intervals always have less than, don't they? So he did that so that the symbol, the form would look the same, a number less than the letter, less than the number. So that's the reason that the left and right chi-squared numbers have to kind of do this when you substitute them in. All right. They also show you in your book a couple things about this chi-squared curve. If you look on page 333, isn't the degree of freedom one less than the sample size? Notice what happens to this chi-squared number when the sample gets bigger and bigger and bigger. Do you see the red one is degree of freedom of 11? I mean 10, so that means there were 11 in the sample. And look at the degree of freedom of 20, so that means there was a 21 what? In the sample. Do you see that the more you have in the study, the more that chi-squared looks more like a normal distribution? Is everybody with me? So it's moving. The other thing is this. Remember when you were doing the other proportions where you had Z numbers? Because you had a normal curve, you had like a positive Z-score and then its symmetric partner was just a negative of that same number. Well, see, chi-squared can't be like that because it's not symmetric. So that's the reason your chi-squared number on the left is not like the negative of your chi. You see what I'm saying? Chi-squared numbers are either 0 or positive. They're positive. But for your purposes, you just have to know what row to look on. That's your degree of freedom, and what column to look under. Now, let me give you one more word of warning. All right, this is what I mean by as you're learning things, you need to look for problem areas. To find the chi-squared numbers, what's the top of the table say you need? You need the area to the what? Right. But go back in your mind in chapter 6, when you were doing values and you were doing inverse norm, what did you need there? The area to the left. So you got to know, when do I need area to the left and when do I need area what? To the right. But luckily for you, the table literally says at the top, hey, you need the area to the what? Right. So hopefully that won't be a problem. Question, Lindsay?
On the test, are we gonna have to like open our book to that page?
No, I don't have, you have just a copy of that. You pick up a copy of the formula sheet, you pick up a copy of table 8. Okay? So any questions or clarifications? All right, now what we're gonna do is kind of preview upcoming attractions. That finishes chapter 7 for us. All right, what we're gonna start next week on Tuesdays, we're gonna start hypothesis testing, which is kind of the reason that you took the class. Is everybody with me? So my job is to get you up to doing some simple hypothesis testing. Then your disciplines can take over from there. All right. So we're going to do hypothesis testing next week. We're going to do it for proportion and we're going to do it for mean. Then we're going to go into the next week. We're going to jump and do linear. We're going to do 2 sample. And then after you come back from Thanksgiving, we're going to do linear correlation. All right. Now, with that said, tentatively, what we're going to do is, I can't believe it is 2 weeks after this before you're off for Thanksgiving, but it is. So on your next test, we're going to have finished chapter 8 and probably do 1 section out of chapter 9. We'll be finished with that by the time you go for Thanksgiving. That's what's going to be on your test. So when you come back from Thanksgiving, your 3rd test will be the Thursday of the week you get back. Okay? Tuesday just sounds like a really bad idea. Okay? Now, Tuesday of that week, we will go on to linear correlation. Okay? But that's going to be on your final. That'll be the only thing on your final exam that you haven't been tested on prior to your final. So you understand, you got 2 weeks of class going over hypothesis testing. Then you go home for the week of Thanksgiving, you come back, your test is that Thursday. But when you go for Thanksgiving, you have all the material. But when you come back, you still got Monday, Tuesday, Wednesday to study in case you should be with your family on Thanksgiving. Okay? The reason, then the next week final start. Like on that Friday. So the reason that I jam up that 3rd test so close to your final is on purpose. Because your final exam is comprehensive, when you're studying for the 3rd test, you're studying also for what? For your final. So that means the next week, when you start studying for your final, you really shouldn't have to study test three material much, because you just what? You just had a test on it. So you really only got to study test one and test two material. So there's rhyme, you know, there's reason to the madness. Okay, where's your homework gonna be? Candace, come see if you need some help.